Alright, that'll do. Composite functions. So your 12 composite functions are when the output of one function, thank you, becomes the input of another. So it's where we represent our function like so, f dot gx, where f, x and gx are two separate functions. And what that means is essentially the value you get for gx will be what you sub in for fx. So to introduce that, I'm going to give us a nice simple start. So say we have fx equals 4x squared plus 6. F of 2 equals, how would we write that line? So wherever you see x, you replace that with 2, correct? So you would write 2 squared plus 6, which equals 4 times 4 plus 6, which equals 16 plus 6, 22. So we're pretty familiar with that. We've seen that sort of notation before. So let's now say I gave you fx, we'll keep fx the same, 4x squared plus 6, and we'll make gx equal, let's just make it 2x plus 1. I want us to find f dot g2. Remember that equals? So what's our first step? Yeah, so before we can sub it into our f function, what are we going to solve, Jet? Yeah, so I would find out what g2 equals first. So g2 equals 2 times 2 plus 1, which equals 5. Mental math is out of this world. And then I would let so what does that equal? 4 times 25 plus 6?
106.
106, good. And that would be our result. Now, really, I don't think you struggle with that too much. Yep, I know, I'm covering it back. I'm about to give you a problem now where I'm not going to ask you to find. Actually, I'll give you the same problem, but instead of finding, I want you to find that. Yep. It's the same thing, but I haven't put a value in. So you've got to figure out how you're going to go about that. I'll show you in a sec, but I want you to have a crack yourself first.